to talk about mercury 1. Because some of you have approached me about it and have been like, hey, what's up with this? And some of you haven't, so let's make sure that we all know about it. So let's say we had mercury 1 chloride. Normally, you'd be like, this is easy. Hg plus, Cl minus. It is HgCl. Unfortunately, this is wrong, okay? And that's because, let's take a look on our data sheets, and we'll look at our polyatomic ion list on the front page of the pink sheet. And if we go up to the top, in the positive ions along with ammonium, you can see we also have mercury 1, which is given as Hg2, 2+. Okay, so mercury 1 is not Hg+, it is Hg2, 2+. What that means is that you have an Hg atom with a plus charge, with a +1 charge, stuck to another Hg atom with a +1 charge. Okay, that is a polyatomic ion. And we cannot simplify polyatomic ions. So if you have Hg2, 2+, and you have Cl minus, you need to balance that charge by adding a second Cl, and your formula will be Hg2Cl2. Normally, that would be something that you could simplify, but you cannot simplify mercury 1. Okay? Mercury 2 is just normal. Okay, mercury 2 is just normal. Mercury 1 is the only weird one. There will only be like one question like that on the test, so if you're like, 1 mark out of 44, whatever, I don't care too much, then don't worry about it, but there will be one. Okay? Yeah. Any other questions about your test? What day is the test? It is on Thursday. And just because I keep having people who are like away and they can't make it and they're not ready for it, everybody is writing it on Thursday. If you're not here to write it on Thursday, I'm going to make sure that I have a version of the test that is harder for those who write it late. Yes? Okay, I have reasonable, I can talk with you. Yes? Right? Like, I mean, there are circumstances. If you're at home puking up a gut, right? Maybe you can like take a photo of the toilet bowl and be like, hey, you don't want this in your room. And be like, okay, no, I don't. Okay, yeah, anyway. All right, but I assume most of you are probably going to be healthy and will be here and you've had lots of time to prepare. Yes? So Thursday. All right. Today we are carrying on with, I need to make this, let's see, we're in atoms. And we were looking at Lewis structures, and we are on page 86. And we're going to make, I'm going to do this, you've got it there for you, but I'm going to just say we have magnesium. And we have nitrogen. Make sure you have your periodic table out so that you can easily refer to it. Page 86, periodic table. Or don't, if you don't want to, I don't rule your life. You can choose to not know what you're doing. Not my choice, but you know, whatever. Magnesium is in group 2. How many valence electrons does it have? 2. Okay, so we got 1, 2. Do we put them together or separate? Separate. Okay, so there's magnesium. Nitrogen. What group is nitrogen in? Nitrogen is in group 15. How many valence electrons? 15 gives us 5. Okay, that 5 gives us 5. So 1, 2, 3, 4, 5. Yes? No? What's wrong? What did I do wrong? I should not pair up here until I have one over on the left. Okay, so I need to have something in every space before I pair up. Okay, so I have magnesium and nitrogen. So how many gaps do we have in nitrogen? We have 1, 2, 3 gaps, yes? So this one's going to go in here. This one's going to go in here. And then we say, oh no, it did not work. What do I do? I just give up and go home. Or what could I do? I could add another magnesium. Doesn't matter. You can do it either way, whatever. But you need to show this anyway, so it doesn't matter which way you do it. Okay, so we got one going there. Yay! Nitrogen is now satisfied. Okay, so this magnesium is satisfied. This nitrogen is satisfied. What about this magnesium? Oh. How could we help that magnesium? Add another nitrogen. Okay. Whoops. 3 gaps. Happy now. What about this nitrogen? Sad. What should I do? Add another magnesium. And you're like, I could be here forever doing this, but you're never going to have more than a 3-to-2 ratio. Okay? Never. All right, so this is going to go in here. This one's going to go over here. There's a reason I'm pausing.
Oh, the arrow.
Arrowheads. Show the directionality. Okay? And when I write my final formula for this, how am I going to write Mg? Mg, how many electrons does it have around it?
0.
0, because it's giving them away. What do I need to do with it? Brackets around in a charge. Okay? So that's 2 plus. Now, you have a choice. You can write that out 3 times, or what else can you do that might be a little faster? You can just put a 3 here. All right? Nitrogen. How many electrons around nitrogen? 8, because they're all full now. 1, 2, 3, 4, 5, 6, 7, 8. Put brackets around it. And the charge. Does that look good? Austin, you look like there might be something bothering you with that.
Because
you're like, I don't know about that. Yeah, there are 2 nitrogens. We need to have 2 nitrogens. Okay, so either draw them all out or write the numbers in front of them. So that is finishing up with ionic ones. We're not going to do any practice right now. I'll let you do some of those for a little later on. For now, we are going to go on to simple covalent compounds. Yes? Okay. For now, we're going to go on to simple covalent compounds. So, Basically, you're forming a covalent bond. You are sharing electrons, because that's what a covalent bond is. And we can just do this by, and this is on page 89. And for the very simplest of compounds, you can start by simply drawing the hydrogen, drawing the other hydrogen, and saying, what could they do? They could share. And what does that look like? It looks like this. Okay, so when you have the two electrons right in between with them very close together, those are shared electrons. We can count, we can say, if I was to look at this hydrogen on the left, it has 2 electrons. Does that satisfy hydrogen? Yes. I can look at the hydrogen on the right and say, is this hydrogen satisfied? Yes, because it also has 2 electrons. Is good? Okay. Each hydrogen has a filled valence shell, and therefore it is stable. However, very soon we are no longer going to draw it like this. Excuse me. We're going to take those 2 dots and replace it with a line. Okay? The line is the same as 2 dots. So if you're counting the electrons around hydrogen, this hydrogen, you would say this hydrogen has 2 electrons and this hydrogen has 2 electrons because that line represents 2 electrons. Is good? Here's some fluorine. Fluorine is group 17. How many valence electrons? 7. How many to make it full? 1 more each. So what could they do? They could share those 2 electrons. Could you draw the structure before flipping the page? What would it look like?
Oh.
Try drawing the Lewis structure 2 different ways before flipping the page. That would be method number 1.
Circle.
We're not actually going to circle anything. Circling is just for you to imagine counting the electrons around each of them. Okay, so the circle is not part of the Lewis structure. Okay, so I might just look at this and I might go, okay, this fluorine has 8 electrons now, right? 2, 4, 6, 8. And this fluorine over here has 2, 4, 6, 8. Because that pair in the middle belongs to both of them. Yes? How else could we write this? We could do the F and a line, which represents those 2 electrons. And we can say 2, 4, 6, 8 around the fluorine on the left. And then around the fluorine on the right, we have 2, 4, 6, and a bond makes 8. Okay? All right, so this just shows what we've got here. This is just showing the 8 electrons, da-dee-da-dee-da. This is what we did. Now, let's look at what we name these types of electrons. The electrons in the middle Those are called a bonding electron pair, a bonding pair. The electrons that are not bonding, non-bonding electrons, are called lone pairs. Lone pairs. So if I was to ask you in fluorine, how many lone pairs and how many bonding pairs? Tell your partner, how many lone pairs, how many bonding pairs? Tell your partner, how many lone pairs, how many bonding pairs? How many lone pairs? Everybody? 1, 2, 3, 4, 5, 6.
Oh, total.
In the total structure, yeah. Okay, in the total structure, 6. How many bonding pairs? That's easy, just 1. Okay, so we have 6 lone pairs and 1 bonding pair. And so that would be, in total of number of electrons, that would be 12 electrons and 2 electrons, which gives us a grand total of 14 electrons, which makes sense because each fluorine brought 7 electrons. So 7 plus 7 is 14. So the number of electrons in the structure has to equal the number of electrons that each atom brought to the game. Okay, so the total number of valence electrons has to equal the number of electrons in the structure. Yes?
What about for like molecular compounds that are like, I don't know, carbon dioxide, for example?
We'll get there.
Okay.
We're doing the simple. Okay? Simple. All right. Please draw Lewis dot diagrams to illustrate the covalent bond formation in Cl2. So you're going to show the original atoms. You're going to draw the molecule both ways, all dots, and by replacing the bonding pair with a dash. Give it a try. Chlorine, Cl2. And I got tired of color coding at the end there. Is good? Is that what you guys got? Hopefully, I mean, this is pretty much exactly like fluorine, but just with chlorine. All right. Let's try something. Oh, let's learn a little vocab here. The octet rule. What does the prefix oct mean? Oct means oct. Come now. 8. It means 8. Okay? So basically what everybody is trying to do is every atom is trying to have a noble gas electron configuration. What is a configuration? A configuration is how the electrons are arranged. And how many electrons are there in a noble gas other than helium? How many electrons in a noble gas? Valence electrons, sorry.
0.
Okay, how many electrons in the valence shell of a noble gas? There are 8 electrons, okay? So we have 8 electrons. That is what we call a complete octet. All atoms are trying to get a complete octet with the exception of, who doesn't want 8? Hydrogen. Hydrogen only wants 2 because it is filling up shell number 1. All the others are filling up shell number 2 or shell number 3 or shell number 4, okay? So here is an example of different atoms. Oh, and the fact that they're all trying to get that complete octet is called the octet rule. Okay, everybody's trying to get 8 electrons except for hydrogen. Okay, so here's HF. And we have an unpaired electron here, and we have an unpaired electron here. Those two are going to get together and share. And we can have that little shared pair there, or that pair there. That gives hydrogen 2 electrons. How many electrons does it give fluorine? In total, it gives fluorine 8 electrons. Remember, you always count the line as 2 electrons. Okay, there's some practice here. We're not going to do that. Let's look at water. Okay, we have hydrogen. Hydrogen is going to get together with oxygen. There's a gap here. There's a gap here, so they're going to share. Hooray! Hydrogen is now satisfied. Yes, it has 2. Is oxygen satisfied? No. So what are we going to have to do? Add another hydrogen. Okay, so we're going to do that. And we will do that like this. Here is our hydrogen. Let's make this hydrogen red. There we are. And that's why water is H2O, because that allows oxygen to get a complete octet and hydrogen, each of them, to get a 2 electron configuration. Yes? Okay. So let's ponder this for a moment. If I have hydrogen and it's got its 1 electron and it is full, how many bonds can hydrogen form? You guys are so passive.
What exactly are you asking?
I'm asking, can I have hydrogen do this? Can it have 2 bonds? Can it have 3 bonds? Can it have 4 bonds? How many is its maximum? Well, let's take a look at this one here. Here we have hydrogen. And it's got a bond, right? Which is 2 electrons. And there's the oxygen. Another hydrogen. There we are, like that. Is hydrogen able in that shell, in that first shell, is it able to accommodate any more electrons? Will that first shell hold more than 2 electrons? No. Therefore, hydrogen cannot have 4 electrons or 6 electrons or 8 electrons. Hydrogen can have a maximum of 2. Okay? So hydrogen can only ever form how many bonds? 1 bond. Because that's 2 electrons, and that fills shell number 1. Does that make more sense now? Yeah? Or are you just nodding and smiling? Okay, cool. All right. How many bonds can oxygen form? Let's try that. I'll go on to the next page. How many bonds can oxygen form? Remember, we have a gap here and we have a gap here. Chat with your neighbor about that. Doesn't it get boring to just sit there and not interact? Like, wouldn't you find it boring?
Yeah.
Yeah. I would find it boring just sitting there. Like, I would fall asleep if I didn't interact. What's happening? How many bonds can this oxygen form? How many will fill up its outer shell? 2 bonds, right? Because we could have a bond with, say, a hydrogen here and another bond with, say, a hydrogen here. Remember, the electrons in between, that is a bond. So how many bonds can oxygen form? 2. Okay, and here we have our oxygen molecule. Bond number 1, bond number 2. So it has 2 bonding pairs. And how many lone pairs? 2 lone pairs. Two pairs and 2 pairs gives us 4 pairs, which is 8. Yes, yes. I was excited. I thought you were going to ask a question or say something. Okay. Anyway, just so we know, it does not matter whether you position the hydrogen on the side or the bottom, or you could place it on either side. Either one of those is okay. All right. And this is the Lewis structure for water. This is also the Lewis structure for water. And we could also, could you draw the line structure? The Lewis structure with lines instead of dots for bonds. We would simply replace the bonding pair with a line. Okay, that is also the Lewis structure. Any of those forms are good. They're all Lewis structures. Yes? Okay. And we could do it this way too. La la. Whoops. La la. La la la. La la la. La. Yes? Okay, good. Excellent. Question for you. How many bonds can N form? Chat with your neighbor about that. How many bonds can N form? N is group what? 15. How many valence electrons? 5 valence electrons. So it looks like this. N, 1, 2, 3, 4, 5. Hold up your fingers to show me how many bonds nitrogen can form. Okay, 3, because we've got a gap here and here and here. So if you wanted to make the molecule NH3, what would that look like? We would have nitrogen, and we have 1, 2, 3, 4, 5. Each hydrogen, and just so you can tell the difference between them, if you don't happen to have a red pen, you can actually use a little X to show the electron from a different atom. Does that make sense? So you can tell, oh, that electron came from hydrogen. That electron came from hydrogen, and that electron came from hydrogen. So if we count up all the electrons in there, we have 8 electrons total. 2, 4, 6, 8. And let's remember, nitrogen had 5 valence electrons. We had 3 hydrogens, each of which have 1 valence electron. So how many valence electrons do we have from all 3 hydrogens together? Each hydrogen has 1. We have 3 hydrogens, therefore we have 3 valence electrons. Okay? Like 3 times 1 is 3, folks. It is. And guess what? If we add up 5 and 3, we get 8, which tells us that at the very least, our structure has the correct number of electrons in it. And also, it's following the bonding pattern for nitrogen. Nitrogen tends to have 3 bonds. Okay, oxygen tends to have 2 bonds. Hydrogen can only ever have 1 bond. Yeah? One of the key steps in writing any Lewis structure is to identify the central atom and who are the surrounding atoms. There are a few tricks to figure out who is the central atom. Number 1, can hydrogen be a central atom? Can it go in the middle?
No.
Can I put hydrogen in the middle and put other things around it? No, why not?
It's easier to filter. No.
Because hydrogen is full with 2 electrons, which is only 1 bond. How can you be in the middle if you've only, like, if you're like, I'm going to hold on to people and you only have one limb to hold on with, you're only holding on to one person, right? If you're oxygen, you got two limbs. Yeah? You can hold on to two people. If you're nitrogen, you have three limbs and you can hold on to three people. Yeah? But hydrogen is full with only two electrons, so it can form only one bond, so it cannot be a central atom. One bond is two electrons. Two electrons fills hydrogen's shell. It can't bond anymore after that. So only one bond. So first of all, you want to think of things like that. Hydrogen can't be a central atom. Do not put it in the middle. How about, can chlorine be a central atom? What should you be thinking about? You should be thinking about how many limbs. Yes. How are you going to look at the number of limbs? What should you be drawing for chlorine? You're going to draw the Lewis dot structure. Okay, so we've got Cl. How many dots? 7. How do we know it's 7? It's in group 17, therefore it has 7 valence electrons. Okay, we have a pair here, we have a pair here, we have a pair here, and then we have a gap here. Every time you have a gap, that is a possible bond. A gap is a possible bond. So in general, how many bonds does chlorine form? 1. So can chlorine be a central atom? No, because in order to be in the middle, you need to be able to grab more than one thing. Okay? So how do we know who's the central atom in general? Actually, it's really easy. If you look at PCl3, usually it's the first element. And it's also going to be the singleton element. Okay? P is a singleton, and it's written first. Now, I don't know if you guys know this, but when we write chemical formulas, we generally go from left to right across the periodic table. P is here, Cl is to the right of it. So in our formula, we write P before Cl. Yeah? And remember, as we go across the periodic table, we are also filling in the gaps with electrons. So phosphorus has 3 gaps, sulfur only has 2 gaps, and fluorine only has 1. Chlorine only has 1 gap. Okay? So phosphorus can form 3 bonds, sulfur can form 2 bonds, chlorine can form 1 bond. So it makes sense that the further left something is, the more likely it is to be the central atom because it has more gaps. It has more ability to form bonds. So what that means is that the central atom is usually first in the formula. and it is usually the singleton. Do you know what I mean by the singleton? It doesn't have any subscript, right? We got a P and there's nothing there. Cl3. So there's only one, okay? One of the P. All right, so we can have PCl3. We've got a P, a P, a P, and a Cl, and a Cl, and a Cl. You don't have to draw the dots. You can just go straight to the lines. Okay. And then let's count up our electrons and make sure there are the correct number of electrons in this structure. So what I would like you to do is I would like you to look at this structure, the entire thing, and tell me how many electrons in that structure. Shall we try it? 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. Is that how many we get from one phosphorus? One phosphorus has 5 valence electrons, VE for valence electrons, because it's in group 15. We have 3 times Cl, which means chlorine has how many valence electrons? Chlorine has how many valence electrons? 7 valence electrons, which gives us 21 valence electrons. So in total, we have 5 plus 21 is 26. Do we have the correct number of electrons in our structure? This structure has 26 electrons. Did the atoms bring 26 electrons? Yes, they did. So that means that our structure has the correct number of electrons. At this point, you're probably like, how could it possibly not have the correct number of electrons? Don't worry, we'll get into places where we have double bonds and then you'll really have to check. Okay, I'm having you check on these easy ones now so that you get in the habit of checking later. The other thing you need to check is you need to make sure that each atom has a complete octet. Except for who?
Except for
Hydrogen, which only wants 2, but we don't have hydrogen here, so it doesn't matter. Does this chlorine have 8 electrons? Yeah, it does. 2, 4, 6, 8. Okay, so you go around and basically you see, do I have 2 electrons on the top, on each side, and on the bottom? Okay, that'll tell me if it's got 8. So for phosphorus, I'm actually going to erase all of this because it's gotten really crazy. For phosphorus, we have 2, 4, 6, 8. What about for our chlorine on the right? 2, 4, 6, 8. 2 electrons on each side. And this chlorine at the bottom, 2, 4, 6, 8. Everybody has 8 electrons. All right, so you got to keep those in mind as we get into more complex structures. Everybody needs 8. and your electrons in need to equal the electrons at the end. Okay? All right. How many bonds can carbon form? Carbon. Carbon is group what? 14. So it has 4 valence electrons. 1, 2, 3, 4. It can form 4 bonds because there are 4 gaps. And that's one of the reasons why carbon is the basis of all life, is because it can form so many bonds, it can form pretty complex molecules. All right? So if we look at carbon, here's carbon tetrachloride, and you'll notice that it starts to get really ugly when we use the dots. Yes? It becomes confusing to look at. I'm like, which dots belong to which atom? Right? It looks, it gives me, I don't know, it's just hard to deal with. My brain deals much better with a line saying, oh, those are 2 electrons that are shared between the 2. Okay? This is carbon tetrachloride, and this is silane, silicon with 4 hydrogens. Okay. What time is it? Okay. Okay, I am going to have you guys do pages 93 to 95. Actually, let me see. Yeah, that's okay. It won't take that long. It looks long, but it's not long. 93 to 95 and 86, 87. Okay, you've got about 20 minutes right now. Should be able to knock off quite a number of those if you're fast. If you're like dilly-dallying, you'll have a lot of homework. So no dilly-dallying. Do you guys know what dilly-dallying is? Oh, look at my phone. Okay, no dilly-dallying.
Did I do my physics dallying?
Physics dallying? Oh, that was exciting. Sarah, do you dilly-dally? No. Sometimes. Okay, because we're going to do it another way. Okay, here we go. Yeah. Hi. Yeah. Do you know where they are? I'll show you. So we have 9A. It's 10. So there's 10A. Okay. Yeah, just you'll have to go back. Oh, there's a lot of water. Yeah. Yeah. You may. Yes. Right? And I have a few quizzes to give back to you, Ethan, Brennan. Ayush. And Jacob's not here, so that's good. Okay. Oh, what? I was in your bag. They're up. So one. Oh, folks, on pages 86 to 87, these are ionic. Oh. So these ones, you need the atoms, you need the arrows, and you need the ions. These guys here are covalent, and this is where they share. Okay, so watch out for that. Yeah. So these ones are going to be like this line where you draw the arrows. Yeah. 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 Okay, stay next. Yes. This one goes in here, and this one loses it all together. Another page, so it's not like this. This has 0 and that has 0. But everything else is you would have brackets, charge. Yeah. We don't mean like from through go around this. Start with lines. Show. Where you need to show atoms, you start with the atoms, okay? Oh, yeah. And then we say, okay, now this page has nothing left. Okay, has nothing left. This has now. Okay. That's all that is.
I know. My spirit was like, I'm not gonna get the whole thing. I've been at the big step. That's my strongest suit. I have a graph on top.
The atoms, which is good. And then, so all you do is in seconds. We are done again. You want the other one? I think it's okay. Underrated. The grown up thing to do was too much. We're seeing a child. Yeah. So I don't get not ready to do it. I don't say it's good practice. We're back to the and it's now sit back. So there are enough people in this class who are unable to handle having their phones. So next day, when you come into the class, you're going to put your phones into the cell hotel first thing. Okay, I'm not going to have you do it now because there's only 10 minutes left in class. But next day, everybody comes in, you come up here. It's alphabetical by last name. So if you are in my block A, in my first period class, I've got someone with the last name Alexson is up here, and over here I'll have one, and then I got my J's and my L's, and down here I got my W's and Y's, okay? So that's what's happening next day because there will be sufficient people who are unable to figure out that class time is not phone time. I know you were doing physics, it's okay. And if you have a reason for using your phone, you may ask me if you can use your phone because sometimes you might need to watch a video for something or whatever. Okay? Hi. Well, because this is my and then you have to get rid of two. Okay, you need to stop spelling this word wrong.
The spelling is my
No. It's the same word all the time. I want you to see if you can see it.
Which line is it?
It's the first line. I want you to read that out loud.
Copper to carbonate tetrahydride.
Okay, that doesn't say carbonate. That says carbonate. Okay, I'm just gonna erase it for you. I'm just gonna erase it for you. But on the test, I'm not gonna erase it for you. It'll be a half a point. So, carbon. How would you spell carbon? Would you spell carbon? So why are you spelling carbonate with a CH?
That's a good question.
Right? It's carbon. Okay, so think of it as just carbon and then add 8.
Yeah, I know it, but I just don't write it.
I know. Do you know what? It's okay. I have a girl in my last period class. Her name is Caitlin. I know her name is Caitlin. She looks like a Caitlin. I have no problem knowing that her name is Caitlin. Every time I go to say her name to her, I say Chelsea. And I'm like, what is wrong with my brain? So you just have the same problem with carbonate, right? Your brain is just stuck in a little glitch there. Okay, so I'll give it to you this time. Okay. This is a 6.
Oh. Yeah, that was a 6.
Yep. And this is a 3 minus.
Yeah, so it's 2. That. Yeah.
Yeah?
I
You
know,
got the
I
2 in the
knew it
wrong
too.
place.
You
knew it was 2, you're just in the wrong place. That's okay.
I don't know.
Okay. We don't have acids in the middle of a compound. Yeah.
What is
So
it?
that's lithium bisulfate or hydrogen sulfate.
White bisulfate.
Because.
Oh, yeah.
Where's my pink sheet?
Oh, yeah. Okay, I remember. Yeah. Maybe don't rush.
Yeah, maybe don't rush because you know what else you forgot?
Like everything else.
Brackets.
Yeah.
Right? Ammonium thiocyanate. No, that's good. Okay.
Oh, yeah.
Potassium permanganate dihydrate. That one's good. Okay. Okay. Thank you very much. I'll mark this for you. Hi.
So this whole time, right? I don't think I've gone to Unit 3 answer key.
Oh, let's go get you one.
I feel like better off in the 2. They were talking about empowering students. And they need them. Like, right if the name drop was clean, I would like, I don't have any drop. Chill guy. He's taking my position. He's still Nathan, that is
Yeah, so.
okay. The art is not very straightforward. It's like you what do you guys like invite me on the test?
I'd rather just go look at what's on it.
Yeah. Like these are like yeah, you be on the test. Yeah, she used to do that. I remember that. Oh, and I'll be happy. No, like this comes out. He's like, my dad is physics. The first thing it's like a tableau reacting out. It's super nice.
He's got trained.
Like seriously, I might even ask me what class I had. Sorry, after class I took physics. Literally right after physics, I went, Mr. McLean. The sample apparently pretty good. I know he's here for urban stories. I just got this teacher out of my goodness. Yes, no. You know, it's hard to get into this. You know, I'm a public It's been vacation. I want to rip this from Jay's face. I know. Welcome to your life.
Vegetable bills. Well, I did like. No, Doritos. Yeah. I don't know. That's the humble, bro. It's not hard, bro. I feel like I'm done. You know, it's fun.
You know what's the worst thing? When one of your peers tutoring students goes, "Hey, I'm in math 11 stream. What are you getting in math 11?" I'm TP right now. They're like, "Ah, 96. I'm better than you. I'm better than you." I just start yelling at them. Why did you just say like, "Oh, I'm getting on"? That's a lot.
Down, yes. Come on.
No one wants to admit. I've had
Some people just start as smart as and then I don't think I'm busy. I know 6 years ago. Yeah.
Well, I would have told you.
Secret strong.
Alright, that's it. Right, when do you know?
Hello. Yes.
Could you remind me what dimensional analysis is? Like, just tell me what it is.
Times, line, cancel the units.
Oh, okay. Can I know how the enriched works in it? Because I don't know the table.
Cubed.
But then I did all of the cubes. So how did I lose marks there?
I don't know. What?
Because I did all of them.
I don't know. I'll have to look at your test.
I remember because
No, you did. So let me just look. Hang on. B. This one.
I need to take 3 per second.
There.
Yeah, you gave me 0 marks for it.
Let me just fix that for you.
Yay! Thank you.
I
That
don't
means
know
I
what's
don't have to do
happening.
it. You're too tired. You need a break. Have a Kit Kat.
Oops.
You know
Give
what?
yourself a Kit Kat. Give yourself a break.
Let me give you a Jolly Rancher. Which flavor do you want?
Do you have watermelon?
Okay.
Where's
Obviously. La.
the wind making?
There it is.
Thank you. That makes me so happy.
I would give you another one, but it's for my kids class.
Oh, yeah. I need motivation too. Thank you. Okay. All right, friends. Hi.
I have a question.
Mm.
And it might be a stupid question, but I just thought of it. Is it possible I could get an outline of everything that is going to be in the test? Because I do have the other movement, right? And then that's listed everything for like part 1 and 2 and 3, everything. But I was just wondering if that's
I don't understand. Sorry. And I got this thing in my mouth and it's taking up so much space and I sound so rude.
So I was thinking if I could get an outline of everything that is going to be